Good day. This is AI mathematics, and don't forget that we have further maths in mathematics. That is why, uh, and for SS3, their scheme of work, especially for those of you who want to write further mathematics in WAEC, start with partial fraction. You start with partial fraction. I know from primary school, you all know what I mean by fractions. You know what I mean by fractions. We have a proper fraction, improper fraction, and we have a mixed numbers or mixed fraction. That form. And when we talk about fraction, you know that something has to divide something. Let's say you have a 3 over 5 now. It's a fraction. 7 over 2 is a fraction. And this is a example of mixed fraction or mixed number. But when we now talk about, and the top one we call it numerator, while the one at below we call it what denominator. But partial fraction is not all that is also a fraction, but it contains algebraic fraction. And what I mean by algebraic fraction? Algebra has to do with numbers and letters. Numbers and letters. Number and letter. Let's say you have 3 over x plus 1 now. You can see that that one contains numbers and also contains uh, letters, x. Let's say plus 4 over 4 over x plus 5 now. This kind of algebraic fraction. But partial fraction is opposite of this. Because now, if we simplify this now, our final answer is where partial fraction starts. Our final answer when we simplify this is where partial fraction starts. Okay, let me simplify this now. To simplify this, like what we were doing in primary school, you find the SCM. SCM means lowest common multiple. And because this one is not obvious, you cannot know if it's 10 or 5 or 15 that is a lowest common multiple. In that case, just multiply the denominator. What you have here, multiply the 2. It will be your SCM. That will now give us uh, that's s plus 1, s plus 5. That's our SCM. Then do normal. You can see that you have s plus 1 here. I can apply now. So, which means, if they say how many here, it means that you multiply 3 here. Because if you want to know, x plus 1, s plus 5. When you divide it by s plus 1, this one will cancel each other, which means you multiply this only by 3. That will be 3 into bracket s plus 5. Likewise, you plus 4. You multiply this one also by s plus 1. S plus 1. So that's a simplify. Then when you do is you have 3 times x, that's 3x. 3 times 5 plus 15. 4 times x, 4x. 4 times 1 plus 4. Everything over s plus 1, s plus 5. So when we add 3x plus 4x, that will give us 7x. 15 plus 4 plus 19, and over s plus 5. This we have simplified this and we got this. Our fraction is always in this form. It's only the form. This is where our partial fraction will start. Then we have uh, fraction. We have types of it. Type of it. It means that I can resolve this now. I can resolve this and get 3 and 4 back. I can resolve this now and get 3 and 4 back. So, for instance now, resolve this one into partial fraction. Resolve 7x plus 19 over s plus 1, s plus 5 into partial fraction. Just simple. Just start with x plus 19 over s plus 1, s plus 5 equal to, we don't know the value, maybe it's 7 or 19 or 2 or 1, but just write a or any letter you want over the first here, that will be s plus 1. Write b also to indicate that you are looking for two numbers, but x plus 5. Now, you find the LCM of this. The LCM of this, s plus 5. So this now be equal to, the LCM is s plus 1, s plus 5. This multiply this, you have a s plus 5 plus b s plus 1. In that case, you can see that numerator are equivalent. When numerator are equivalent, it means that when denominator are equivalent, they are the same thing. It means that numerator also will be what? The same thing. Just equate numerator to numerator. We have 7x plus 19 equal to a s plus 5 plus b s plus 1. You forget about the denominator. They have cancelled each other. But we want to find a and b, but we cannot find the two together. We cannot find a and b together. We find one and leave other, while we find the other later. Now, that's why if you are a science or mathematics student, you'll be able to think. While you think, you can see that you want to find a now. Just think how to make this, what we have inside this bracket, to be 0. And to make this thing to be 0, which means you multiply b by 0, everything will be 0. In that case, for me, I already know what I can add. Let x be minus 1. Let x equal to minus 1. You now substitute the value of s in all this. That will be 7 minus 1 plus 19 equal to a minus 1 plus 5 plus b equal to minus 1 plus 1. You can see now that 7 times minus 1, that's minus 7 plus 19 equal to a, this 4, plus b equal to 0. Our aim is to get 0 in the bracket, and we are able to get it. and b times 0 give us 0, which means minus 7 plus 19. That will give us what? 12. 12 is equal to uh, 4a, which means our a will be equal to 12 over 4, which is equal to what? 3. So we are able to find the value of 3. Now, we want to find b. We want to find b now. To find b now, you think the same thing. How we make everything here is 0 is by using minus 5. To find b, let x be equal to minus 5. We now have 7 minus 5 plus 19 equal to a minus 5 plus 5 plus b minus 5 plus 1. 7 times minus 5, that's minus 35 plus 19 equal to a, this one give us 0, plus b equal to minus 4, equal to minus 4. You can see that we have been able to get the value inside the bracket to be equal to a 0, which is our target. Now deduct that's 35, that's 19, that's 6, that's 1. So this one give us minus 16. That gives us minus 16 will now be equal to minus 4b. That's 4b is equal to 16, or b is equal to 4. You can see that we are able to get the value of a and b. Now, what we solve from the end where algebraic fraction end is where the partial fraction starts, which means the partial fraction is a fraction, is a algebraic fraction that is compounded, joined together. Partial fraction is but our aim is to find separated one, individual value of it. So that's instead of this. Then because of this, now I want to introduce types of partial fraction. Types of partial fraction. Type of partial fraction. We have partial fraction, linear and non-repeated fraction at the denominator. Types of partial fractions. We have those with non-repeated linear factor at the denominator. Non-repeated linear factor. Non-repeated linear factors as linear factors as the denominator. What that means that non-repeated linear factors is a factor that contain the highest power is, let's say you have x plus 5 now. It's a linear factor because the power here is just 1. But when you have x, that one is no more linear. This one is quadratic. And repeated, when something repeated, which means you have s plus 5 squared. This one is repeated. That's what I mean by non-repeated linear factor at the denominator. I also have Non-linear factor that are not repeated. Non-linear factors that are not repeated. Non-linear factors that are not repeated. Another one, non-linear factors. Non-linear, non-linear factors that are not repeated. Repeated. What that means that, you know, x plus 1 is a linear factor, but x squared plus 1 is not linear. And repeated, which means you don't have x plus 1 square or x plus 1 3. So that's what we call non-linear factors that are not repeated. Likewise, we have those with repeated, linear or not linear. Those with repeated, linear or non linear linear factors. Repeated, either linear is this. When it's repeated, you have something like this. And non-linear, x squared plus 1, and you have x squared plus 1. This one then we have improper fraction. Well, we have improper fraction. This improper fraction, you can see that in partial fraction, the degree of denominator is always greater than degree of numerator, especially for first, second, third type. Degree means the power at the denominator will be more than the power at numerator. But for improper fraction, the degree may be more than the degree of denominator may be more than the degree at numerator, which means power at numerator may be less than the one at numerator, which means numerator will be more than or equal to. In that case, we use long division by polynomial method to resolve it so that the degree of numerator will be more than the degree of numerator. Then we now resolve into partial fraction. So on this note, next class I will try to take it one by one, different type, and I will show you how to solve it. So thanks for watching me. Like me, share me, and follow me.